Hello to all the judges. My name is Muzammil Adib and today I am going to do my poster presentation for my FIP project Design of a DC-DC converter for the MPPT application of PV system. The research problem for this project was identified such that the efficiency of the PV array is low as the power generated by the solar panel is influenced by the climatic conditions and depends upon the solar irradiance and temperature. The PV panel demonstrates a non-linear performance and has a single power peak at a specific condition that is known as maximum power point. To acquire the maximum power from the solar panel, the load impedance should equal the source impedance that necessitates the need of impedance matching circuit. This impedance matching circuit is called DC-DC converter that is required along with the MPPT tracker to retain the constant output voltage irrespective of the altering input and the load variation. The circuit of the DC-DC converter for MPPT application was constructed and designed in MATLAB Simulink software. The input to the DC-DC converter circuit was supplied from a solar panel under various conditions. The PSO MPPT algorithm was employed to test and evaluate the performance of DC-DC converter. Each parameter of the circuit was designed based on the design methodology and guidelines. To test the designed DC-DC converter under different conditions, the varying voltage was supplied from the PV panel depending upon the solar irradiance and temperature. The solar irradiance was varied from 100 to 200 watt per meter square at the constant temperature of 25 degrees Celsius. For the detailed analysis, the solar panels of different ratings from various solar manufacturers ranging from 80 watt to 300 watt were employed to observe the results and their differences. For the novelty and inventiveness of this project, the design methodology of DC-DC converter for MPPT application was accomplished that fulfilled the objectives of this project. Based on the detailed analysis, it can be recommended that the input voltage range should lie in between 5% to 10% from the VMPP. The second step is to identify the range of duty cycle to be inserted into MPPT algorithm based on the Vin max and Vin min values and the Vout the rating that is being derived from the load connected to the system. In accordance to the values at the standard testing condition, the maximum inductor current ripple and the output voltage the ripple are considered as 40% and 20% respectively to design the inductor and the capacitor values. It was distinguished that the type of DC-DC converter has no direct impact on the MPPT. The choice of DC-DC converter is based on the type of application and load condition is independent of the input. The DC-DC converter is selected for the fixed voltage rating that is being derived from the load. This project benefits the renewable energy source to meet energy requirement and address the issue of poor power efficiency, instability and intermittent behavior. It is essential to apply solar energy for a wide variety of applications and provide energy solutions by improving the energy stability and system efficiency. This study facilitates the efficiency of solar power system that enables it to be a competitive solution in the energy market. It enables the PV system to deliver the optimized and maximum power output to the grid or the standalone system. It is widely applicable in many applications that includes the power generation, telecommunication, agriculture, the water desalination, buildings and the household applications. According to the study done by International Energy Agency (IEA), it shows that the solar energy would supply around 45% of the energy demand in the world by 2050. Based on that, it exhibits a great potential in the energy market. Since this project mitigates the efficiency of the PV system, it facilitates the adoption of the renewable energy solutions by many companies, landowners, organizations, and the governments. It mainly assists the individual from the electrical and electronic engineering field and is projected to be deployed by the major power utilities for their electricity production. In Malaysia, TNB, SEB, SESP are the potential users. Therefore, as the utility industry persists to confront the influence of the environmental hazards due to the conventional energy resources, this renewable energy resource has the potential to combat this challenge effectively. This project also contributes to the sustainable development as it tends to reduce the environmental hazards of the conventional fossil fuel and other energy resources. It is cost-effective, abundant, eco-friendly, and a clean energy alternative. This project has been undertaken to curtail the negative effects of the conventional or the fossil fuel power generation and to reduce its dependency by alleviating the challenges of the renewable energy resources. It involved the sustainable and recycled material for its construction that would lower the manufacturing cost while adhering to the higher efficiency. This project does not contaminate the environment and comply with the environmental standards. All components that were being utilized are recycled at the end of their life. It resolves the issues related to the environment and the society by providing them with energy security, energy cost savings, the reduction in the greenhouse gases, and the business sustainability.